All right. Very good morning to all of you. Good morning, everyone. Good morning. Yes, good morning, Prasad, Akash. Good morning to all of you. Good morning. Let everyone join. Yes, please tell me, are the voice and screen clear? All okay? Tell me yes or no. All okay? Yes? Okay. Okay, tell me what was the last point? Tell me what was the last point? Hmm? What was the last point? Van de Graaff generator. Okay, fine. So there was one reading assignment, okay, for the Van de Graaff generator, which was given to you, page number 53. Okay, construction and working. If you are able to draw the diagram, that's it. You can write the construction and you can write the working also. Okay, construction means writing the names of the components, okay, and describing why that component is there, and describing why that component is there. That is called as construction. And working means with the help of the constructed instrument, how the device is going to work, okay, and how it is to be used, okay, that thing is called as working. So that is very easy to write. Okay, once you just draw the, or once you are able to draw the diagram, everything else becomes very easy. Fine. So today we are going to start with the uh, new concept. Write down along with me, capacitance. Write down along with me, capacitance. Capacitance. We know what is resistance. Actually, resistance is a property. Resistor is a device. Resistor is a device which has a property called as resistance. Okay. Similarly, capacitance is a property. Capacitance is a property, and capacitor is a device. And capacitor is a device. Okay, resistor is a device. Resistor is a device. Resistance is a property. Capacitor, it is also called as condenser. It is also called as condenser device. Capacitor, a device. It is also called as condenser. So capacitor is a device and capacitance is the property. Okay, is the property. Fine. So there is something called as resistance. Resistance is a property because of which the given object or the given substance or the given material opposes the flow of current, sorry, flow of charges or simply current. The property because of which materials oppose the flow of charges, the property because of which materials oppose flow of charges is called as resistance, and the material will be called as resistor. Material will be called as resistor. Similarly, there is some property called as capacitance. Now what is capacitance? We can very easily observe. Write down. When when a conductor, just keep on writing, initially a conceptual thing, so we have to write. When a conductor, sir, handwriting थोड़ी मोटी करा बाळ, zoom कर screen. You can zoom the screen on the mobile. Reply me yes, no, Prithviraj. If it is a shared screen, you can zoom it. Yes? All right. Fine. When आणि मोबाईल हॉरिझॉन्टल मोड वरती वापरा. Okay, use the mobile in the landscape mode, right? When a conductor is charged, its potential increases. Its potential increases directly with the charge. Means potential of the conductor is directly proportional to charge on the conductor. Potential of the conductor is directly proportional to charge on the conductor. Okay, and here just by mathematics we can say that if V is proportional to Q, we can say that Q is proportional to V. Means more the charge on the conductor, more will be the potential. More the potential, more will be the charge. More the charge, more will be the potential. Okay, but this relation we want so that we can induce a proportionality constant called as capital C, and this V as it is, where C is proportionality constant. And name of this proportionality constant is capacitance or capacity. Resistance of the resistor, just like that, capacitance of the capacitor. So capacitance or what is its name? It is a proportionality constant called as capacitance or capacity, or it is directly called as capacity. It is also called as capacity. Now it's a constant. This value is fixed for given material of the conductor. Sorry, not on the material, because if it is a conductor, material will not matter. Okay, basically it is a conductor. It depends on the shape, size, and the surrounding medium. Okay, so just keep on writing about this C. C means what? Capacitance. C means what? Capacitance or capacity just keep on writing. Depends on, it's a constant. So which factors decide this constant that we are writing? Depends on, step by step. Number one, size and shape of conductor. So it matters. Let's say the spherical conductor we have. What is its radius? Smaller, larger, that is means size. Shape, whether it is a sphere, whether it is a circular plate, whether it is a square plate, so on that also it matters. Size and shape of conductor. Okay, once you fix the size, once you fix the shape, automatically this capacity will get fixed. Capacity of the conductor will get fixed. Size and shape of conductor. Number two is what? Number two is given as surrounding medium. Yes, surrounding medium also matters. We will derive the formula of this capital C. In that situation, you will observe that there is a epsilon R, that is dielectric constant. Epsilon R or K, that is the property of surrounding medium. Okay, this point we will understand automatically when we derive the formula for C. Okay, surrounding material or medium. And the third is presence of other conductors nearby. Yes. Okay. Just by arranging two plates, instead of taking one plate and storing charge on that, people take two plates. So these are the two neighboring conductors. And effectively system has more capacity than the single conductor. Okay, so instead of using single conductor, people try to use two conductors so that they can increase the capacity. Okay, just keep on listening the things. Initially these are new things, so just keep on listening and keep on accepting the things. So write down, the capacity also depends on presence of other conductor, presence of other conductors nearby. Okay, they have written it like this, so we will write same as them. Presence of other conductors, presence of other conductors nearby. All right, presence of other conductors nearby. All right, now let us try to find out unit of capacity. These are some basic things, usual things that we generally do. This point is over. Capacity depends on, that's a proportionality constant, that's it. Now taking units on both the side, unit of Q is equal to unit of C and is multiplied by unit of P. Now unit of Q is Coulomb. Let me write it complete, because I will not be writing directly C here, otherwise you will get confused between this C and this C. Unit of Q is Coulomb, unit of capacity that we want to find out, and unit of potential or potential difference, you can say it's a volt. It's a volt. So unit of capacity is what? Unit of capacity or capacitance is what? Coulomb divided by volt. Coulomb divided by volt. Now this C means capacity. Now for Coulomb, let me use again C, same. For volt, let me use capital V. But people call this volt upon Coulomb as Farad. People call this not volt upon Coulomb, Coulomb upon volt. Okay, people call this Coulomb upon volt as Farad, not as Faraday. It's not Faraday. Faraday is a unit of charge. Faraday is a unit of charge or amount of electricity. Amount of electricity means charge. Faraday is a unit of charge. We are not talking about that. That you will talk in the chemistry. Okay, Faraday you will talk in the chemistry. It's a unit of charge that we are not talking about. We are talking about Farad, F-A-R-A-D. We are talking about Farad. आता बोला बाळांनो, up to this point, is that clear? Everyone reply me in the chat box. If you have any doubt, you can ask. CW, good. Yes. Yes. Okay. Clear and written. Good. Yes. Yes. All right. Fine. So there is something called as capacitance. Okay. Step by step we will get it. Step by step we will get it. It is very similar to resistance. Okay. It is very similar to resistance. Potential, current is directly proportional to potential difference. Then by mathematics we say that potential difference is also proportional to current, and then the proportionality constant V is equal to Ri or IR. V is equal to Ri or IR. It's a very similar property. So materials have the property called as resistance, materials have the property called as capacitance. That's it. It's just a proportionality constant for time being. All right. So write down 1 farad is equal to how much? On the next page, write down. It's a SI unit. Farad is a SI unit. 1 farad is equal to 1 coulomb. 1 farad is equal to 1 coulomb upon 1 volt. 1 coulomb upon 1 volt. 1 farad is equal to, this we have to remember. Okay, non-SI unit is there. 9 multiplied by 10 raised to 11 stat farad. This we have to remember. It's as good as 1 meter is equal to 100 centimeter. Okay, it's as good as 1 meter is equal to 100 centimeter. So we don't have any choice. We have to remember this. 1 farad is equal to 9 into 10 raised to 11 stat farad. Okay, just square bracket this. Unit conversion, this we have to remember. There is no second option. Okay, there is no second option. So make a star point to it. Okay, because just because of unit conversion, you cannot just leave that question. Okay, You will solve it and you will remember 1 farad is equal to 9 into 10 raised to 11. 9, 10, 11. Isn't that easy? 9, 10, 11. 9, 10, 11. Will you remember now? Write down here in words. 9, 10, 11. 9, 10, 11. Fine. Next. Now next point, write down. Just keep on writing. This is the first lecture, so here we have to just keep on writing. Okay. Capacitance of a spherical conductor. Okay, we know that conductors have property called as capacity. Potential of the conductor is directly proportional to the charge on the conductor. More the charge, more will be the potential, or more the potential, more will be the charge. Proportionality constant is called as capacity. That's it. Okay, sir. Next. Now let us take one conductor. Let us decide shape and size. Okay, and let us find out its capacity. Fine. Very simple. So write down capacity of a spherical conductor. Okay, sir. Fine. Capacity of a spherical conductor. Capacity of a spherical conductor. So let us take one spherical conductor. Let it be a hollow shell or let it be a solid conductor. Ultimately, if it is a conductor, charge will be only on the surface. So it doesn't matter whether it is a hollow sphere or solid sphere. If it is a metallic sphere or if it is a conductor, charge will be only on the surface. Okay, sir. So let us put some charge on that conductor. Let us put some charge on that conductor. Let us say the value of the charge on the conductor is capital Q. Now let us decide the size of the conductor. Size means radius of this spherical conductor. Let us decide the size as capital R. Let us decide the size as capital R. What is the value of potential? What is the value of potential of this conductor? What is the value of potential of the conductor? Means potential at a point on the conductor. Potential of the conductor means potential at a point on the conductor. Potential of the conductor. Conductor's potential means potential at a point on the conductor. Okay. Very simple. Can anyone tell me or reply me in the chat box? Spherical conductor, potential on the surface. You should not forget this formula. Tell me. Potential on the surface of the conductor. Very good, Advait. Use small r, capital R precisely. Very good, Slesha. Also use small k, capital K precisely. Small k is 1 upon 4 pi epsilon 0. Okay, and that epsilon is equal to epsilon 0 into epsilon r, or that epsilon 0 into k. This k is capital K. Be precise. Let's be precise. Very good, Monali. Everyone? Correct. Sir, potential at a point on the surface of the conductor is kq upon r. But the point is on the surface, so r will be the radius. Point is on the surface, so r will be radius. So we will call this as equation number 1. Now, sir, we know that C is equal to what? Q upon V. Can you observe here? C is equal to Q upon V. Where it is? Here. Q is equal to CV. Can I do the rearrangement? C is equal to Q upon V. Yes, sir. You can do charge on the conductor divided by potential of the conductor. Yes. So write down. Write down first Q is equal to CV, because this is the basic relation that we are going to remember. Other relations we will derive. For example, C is equal to Q upon V, that we will derive. But initially we will remember, all of us, I will also remember with you this relation. I directly know this relation, but I will not use it. Okay, for initial few times.